Last week, brief introduction about the situation of hypoxia. Everyone should be familiar with the precise concept of it and also get to know some of the parameters. To know the real situation inside of human being's body. Today we're going to continue with the same topic, hypoxia. And after introduce the basic concept and some of the parameters, here is a very important curve you need to understand. It is called oxygen-hemoglobin dissociation curve. As I mentioned last time, hemoglobin are the ferry boat that take the oxygen from the alveolar capillary to the terminal, which is the tissue cell end, working as a transportation method. So association, or let's say the oxygen as passengers of this ferry boat, combined with hemoglobin, is association. And this association is like the passengers or the oxygens get off the ferry boat at the cell ends. The dissociation curve is shown, the regular one is shown in the red curve, and there are two variations or the changes to two directions. One is the green one and the other one is the yellow one. Please pay attention to the two axes. The vertical one is the oxygen saturation. What is the normal oxygen saturation? Anyone still remember? For example, you, at this moment, what should be the oxygen saturation? Yes, 95 something. And the horizontal axis, X, is the partial pressure of oxygen. What's the normal range? Think. 100, 60. If you can't give me the right answer, please go back and review the previous slides of this chapter. These are all very important parameters you should remember. So the vertical is the saturation. The horizontal is the partial pressure of oxygen. And here is P50. What is P50? It's 1 measure of the position of the curve, while the partial pressure of oxygen while the oxygen saturation is 50%. What can we read about partial pressure of oxygen? See this one. At the level of 50%, the oxygen saturation, the related partial pressure of oxygen is, yes, a little bit less than 30. That's P50. Now let's get back to the ferry boat example, hemoglobin. Transport oxygen from the lung to the tissues. It's a good thing or a bad thing for the oxygen to dissociate with hemoglobin very quickly, more prone to dissociate with hemoglobin. It's a good thing or a bad thing. Consider the whole transportation process. You may say it's a good thing. At the tissue end, yes, it is. Yes, it is. Why? Because we are taking the oxygen to the tissues to supply oxygen for the tissues to use. If they cannot be dissociated, then the oxygen won't stay in the tissue. It will be flown away with blood circulation. So it's a good thing. It's easier or more prone to leave, to dissociate with hemoglobin. And at the other end, it's not a good thing. It's not a good thing. At the lung end, if it's more easy, more prone to dissociate with hemoglobin, means it's difficult for hemoglobin to combine with oxygen, means less passengers get onto the boat to be sent to all the tissues who needs oxygen. So that's, I think, pay attention. That's one situation. So the dissociation, the ability to combine, to leave the oxygen, it's increased. Now, which line it is, let's have a look. Please pay attention to P50. P50. The yellow one. The yellow one. At the same saturation level, 50. The P50 of the yellow curve is higher than P50 of the red one. What does this mean? The oxygens are more prone to combine with hemoglobin or dissociate with hemoglobin. And the ability of oxygen-hemoglobin dissociation or combination can change to the opposite way, which is the green one, means the red curve move towards the left side. Then the P50 at the 50% saturation level is decreased. It's decreased means the oxygen is more prone to combine with hemoglobin or dissociate with hemoglobin. And I show these three lines because, as I mentioned, either variation to both sides, to either side of this red curve is not good enough. Because if the oxygen hemoglobin are more prone to dissociate, means less passengers get on the boat, then eventually will be hypoxia at the tissue end. The opposite one is if they are more prone to combine together, means less dissociation at the tissue end. In other words, lots of passengers are easier to get on the boat, but they're reluctant to get off when they're at the tissue end. So what is the best? The best one is the red curve at a certain level to make sure we have enough passenger get on the boat, and at the very end we have enough oxygen passenger to get off the ferry boat, which is hemoglobin. That's a red curve. And what can change the red curve to the yellow one or the green one? They're the acidosis, hydrogen ion level, carbon dioxide level, and temperature. The increase of these three factors will cause the dissociation curve change to the right direction, and the drop of these factors will cause the curve to change to the left direction.